Polycarbonate is one of the highest performing engineering thermoplastics available, known for its excellent combination of strength, impact resistance, and heat resistance. Those properties are why it's used in everything from safety equipment and automotive components to construction materials and medical devices. In the world of desktop 3D printing though, polycarbonate has never really become a mainstream material. Despite its impressive performance, it is notoriously difficult to print, known for requiring high temperatures and careful control to minimize warping and shrinkage. A few weeks ago, Prusa sent over a spool of their Prusament PCCF, a filament I've been wanting to test out for some time now. The carbon fiber aims to address some of polycarbonate's biggest printing challenges while retaining many of the engineering-focused properties. In this video, we'll take a closer look at Prusament PCCF. We'll cover what it is, its material properties, what's required to print with it, and of course, we'll do some printing. So with all that being said, and without further ado, let's get right into today's video. Years ago, I tried printing polycarbonate on a fully enclosed printer, but no matter what I tried, the warping was so severe that the end results were anything but impressive. With improvements to overall printer reliability and hardware improvements coming in the form of things like chamber heaters, printing with that material is more feasible than ever, but there are still plenty of challenges. This is what Prusa aimed to address with the release of their PCCF. When this came out, and according to the date back in 2021, I remember being blown away by the parts that they were showing, and even more so the fact that they were being printed on either Mark III or Mark III's that didn't have any sort of an enclosure. With that, there are a few things I want to make sure that I point out. This material is advertised as a PCCF blend. Given that it has both polycarbonate as well as carbon fiber, the fact that it is a blend is relatively obvious, but what might be a bit less obvious is that if we took the carbon fiber out of the equation, the polycarbonate itself is a blend. Looking through the product page as well as the available documentation, I couldn't find anywhere where Prusa discloses what exactly the blend consists of, but clearly it's formulated to improve the overall material printability while maintaining many of the engineering properties that make polycarbonate so attractive. Unless you have a very specific application where you know it has to be just pure polycarbonate, most people are interested in the actual thermal and mechanical properties more so than the exact specifics of what the material consists of chemically. For this, we'll take a look at the technical datasheet, starting with some of its mechanical properties. If you haven't looked at a technical datasheet or TDS for a 3D printing filament, most of them will have two columns of result values. This is because the orientation that the parts are printed in can have a substantial impact on the results achieved. In the case of this TDS, the first column displays the results for the parts printed in a horizontal orientation and the other in vertical. If you scroll down to the bottom page of the TDS, there is a visual for both what the horizontal and vertical orientation look like, where you can actually see the layer lines as well as the machine and printing parameters used to achieve the results in this testing data. We'll run through a few of these values, but for anyone interested in seeing more, just pause the video or check out the TDS PDF file located on the product page.
Today's video is brought to you by PCBWay. With over a decade of experience, PCBWay offers high-quality PCB prototyping and fabrication solutions. Along with PCBs, they also provide CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I've used PCBWay for a range of projects over the years, including small batches of PCBs, plus CNC and SLM parts for custom printer builds. I've always been really impressed with their quality and super fast turnaround times. If you're working on your own project but need some help bringing it to life, check out the link in the description below to see everything PCBWay has to offer, and to get $5 off your first order today.
First up, we have tensile yield strength. This measures how much pulling force the material can withstand before it begins to permanently deform. Here we're looking at around 64 to 70 megapascals depending on the print orientation. Next is tensile modulus, which tells us how stiff the material is. A higher value here means that the parts will flex less under load. This is really where carbon fiber shines, and you'll see this with a lot of materials using chopped carbon fiber. Rather than increasing the overall material strength, you will see an increase to the material stiffness. Here we're looking at 2.6 gigapascals in the horizontal orientation and 3.2 in the vertical. Impact strength tells us how well a material can absorb a sudden impact without breaking. In general, carbon fiber materials tend to trade some of the impact strength for that overall stiffness, so this is a metric I always like to pay attention to. For this section, Prusa reports two different Charpy impact tests, the standard and the notched. While the way these tests are performed are near identical, in the notch test, they introduce a small notch into the sample part to create a stress concentration. This makes the notch test the more demanding one of the two and evaluates how well the material resists crack propagation. Comparing these numbers to the TDS from the standard Prusament PC blend, this shows us exactly what the carbon fiber is bringing to the table. Tensile strength remains fairly similar, but the stiffness sees a significant increase. Both the tensile and flexural modulus jump, meaning parts will flex much less under load. This makes the material ideal for structural components, brackets, and fixtures where rigidity matters. The key trade-off is in impact performance. The regular PC is so tough that it didn't actually fracture using the standard Charpy test. One other value I definitely want to highlight is the heat deflection temperature, or HDT. This measures the temperature at which a material begins to deform under a constant load. The HDD value tells us how a printed part is likely to perform when it's both hot and under stress. Prusa reports two different values: 114 Celsius under a 0.45 megapascal load, and 106 Celsius under a much higher 1.8 megapascal load. As you'd probably expect, applying additional force will cause the material to deform at a lower temperature. Even so, a heat deflection temperature of above 100 Celsius is really impressive, and depending on what your application is, may be one of the reasons why you'd choose to use polycarbonate. Now that we know a bit about the material properties, let's go over what's actually required to print with it. Thankfully, most of the important information is available right on the product page. Let's start with the hot end. Prusament PCCF has a recommended printing temperature of around 285 Celsius. While this is on the higher end of any sort of standard materials most people will print with, it is still below that 300 Celsius number, which is the cap for a lot of hot ends. So as long as you've got an all metal hot end, just about any hot end should be able to print with this material. Although polycarbonate on its own isn't particularly abrasive, the addition of the chopped carbon fiber means that you will need to use a hardened steel nozzle or some other variety of a wear-resistant nozzle. A brass nozzle will get completely chewed through. Moving on to the bed. The recommended printing temperature for the bed is around 110 Celsius. This is also on the warmer side, and even when I'm printing ABS or ASA, it is rare for me to take the bed above 100 Celsius. On the product page, they do say there's sort of a tolerance of plus or minus with the printing temperature, so as long as you can hit 100 Celsius, I think you'll have no problem printing this material, but there are printers out there that can't get above 80 or 90 Celsius, so I would verify that your printer can at least hit that 100 Celsius temperature before picking up some of this material. Finally, for the print surface, Prusa recommends PEI. If you're using smooth PEI, you'll need to put down a bit of glue stick to act as a release agent, otherwise you will run a serious risk of the part bonding to your smooth PEI. If you're using powder-coated PEI, or in my case I'm using the satin PEI sheet, you don't need to add any sort of release agent. Cooling is listed as not recommended on the product page, but when I took a look at the TDS, there is a little bit more context surrounding that. Here it states that 20% part cooling can be used for bridges, but cooling in general is going to have an impact on the material's overall interlayer adhesion. That brings me to my next point. On the product page, it states that you can print this material without an enclosure, and I remember being blown away 4 or 5 years ago now when they were printing this filament on the Mark III or Mark III's on a completely open frame. With that being said, my recommendation is absolutely to use an enclosure, if at all possible, when printing with this material. If you're buying and printing with a material like PCCF, chances are high that you are printing something functional where strength and reliability actually matter. An enclosure is going to help provide a more stable printing environment and remove issues caused by things like drafts or just other environmental fluctuations, which will help to ensure you have the best possible interlayer adhesion that you can achieve and that the parts are as strong as they can possibly be coming straight out of the machine. A little higher up on the page under pros, it states that this is a filament that does not need to be dried. And while I generally don't mind drying materials, and I do that with things like TPUs, PTGs, and sometimes ASAs, it is certainly a nice perk. It's also worth mentioning that a lot of the consumer grade filament dryers don't actually get all that hot, so I'm not convinced they would do a fantastic job of drying this material, even if this material needed it. For the printer, I'll be using the Prusa Core 1 Plus. We just finished maybe a month and a half or 2 months ago converting my Mark IV to a Mark IVS to the Core 1 Plus over on livestream, so I have been running trays and trays of parts for the Cassadio Unimog. It's a 1/7 scale massive RC truck. For the majority of the body parts and frame, I'm sticking with PETG, but for some of the gears and some of the gear housing, I wanted to use PCCF, mostly for its temperature or heat deflection temperature. Also, the stiffness of those components I think is going to help with its overall longevity. I started off by selecting the built-in Prusament PCCF profile in Prusa Slicer, and then adjusted the layer height and strength settings to match the requirements for the Unimog parts. The default profile uses a hot end temperature of 285 Celsius, and for the bed, it has the first layer set to 110 and 115 Celsius is used for the rest of the print. One thing I found a little interesting was we just discussed the fan and how the product page said no cooling, but the TDS said 20% is okay for bridges. Well, in the default slicer profile, they actually have it set to a minimum of 15% and a maximum of 30% part cooling. Since I selected the structural profile, the overall speeds were fairly conservative. The fastest moves were 120 millimeters a second for the sparse infill and 140 millimeters per second for the solid infill. But even with that, the filament's max flow rate was capped at 9 cubic millimeters per second, which ultimately would have been the limiting factor regardless. With everything sliced, I sent off the first tray of parts to be printed. I've really only had the last month here or so to start printing out on the Core 1 Plus, but one thing I've noticed, especially for materials like PETG, ASA, and now PCCF, is that before printing, the machine does a heat soak. For PCCF specifically, between the heat soak getting the chamber up to a certain temperature as well as doing the bed leveling, it was about 30 minutes from the time I hit print to where the printer actually started laying down filament. Now for any of these prints, you do have the option to skip the heat soak, but because these parts need dimensional accuracy and because I'm going to be driving them off-road on rocks and stuff like that, I want the best possible interlayer adhesion I can achieve. So for all the prints, I've just let it soak. The finished parts look fantastic. Surface quality was excellent, and the only small imperfections I found were on some of the more extreme overhangs. This is likely the reason why the print profile has a bit of part cooling from that 15 to 30%, while the product page and TDS generally recommend against it. Many of these parts also required a significant amount of support material, and with how stiff these parts are, it did take some work to remove them, but outside of maybe a little bit of a lighter white or gray area, I was impressed with how cleanly they came off. Using the Core 1 Plus and the built-in profile felt a bit like using a cheat code, so I also wanted to use a different machine so I can throw together a profile and just see how this material performed on that. I've been testing out the FlashForge Creator 5 and Creator 5 Pro tool changers, so I used these settings in Prusa Slicer to generate a profile for PCCF in FlashForge's Slicer. I largely kept the settings the same, but I did round up the max flow from 9 to 10 cubic millimeters per second, and on the Pro model it has a chamber heater, so I did set that just to 45 Celsius since it didn't do the same heat soak that the Core 1 Plus did. Given how well the material had stuck to itself as well as the build plate, the intention of the chamber heater wasn't really to provide more heat, but more to provide a consistent printing environment. And because of the large top hat on that, I wanted to make sure that everything sort of got up to temperature, if possible, before it started printing. Well, I'm happy to report the parts that came off the Creator 5 Pro were every bit as impressive as the ones I got on the Core 1 Plus. Print quality was essentially identical. The only difference I noticed came when I went to remove the parts from the build plate. On the Core 1 Plus, I had been using the Prusa satin sheet, and whenever I flexed the parts off, they pretty much all came off in one go, while on the Creator 5 Pro, it uses a powder-coated PEI sheet, and some of the support arms on the organic supports stuck down to the build plate and just took a little more effort to remove, but that is just because of the print surface, and if you use powder-coated PEI instead of satin on the Prusa, you're likely going to have a bit of additional bite as well. Since then, I've been running tray after tray of parts. I still have quite a bit more to go. I think for the model or the version I'm building, there's like 580 parts total, but I am really excited to get this project started, get things assembled, and see how these parts hold up when I take the truck out onto a trail. At $64.99 for an 800 gram spool, this is definitely not something you're going to want to use for just your everyday printing. But if you have an application where stiffness, dimensional stability, and heat resistance matter, well, it's easy to see where this material shines. On top of that, the PC blend with the chopped carbon fiber just makes the end result look absolutely stunning, and this is by far one of the easiest, if not the easiest, PC variant materials I've ever printed with. And that has been Prusament PCCF. I hope that you enjoyed this video and that you have a better understanding of what the material is, what's required to print with it, and if it makes sense to use for a specific project or application you are facing. If you have any additional questions, let me know in the comments down below, and I will do my best to answer. On that note, don't forget to like and subscribe for more great videos. We make a video just about every other week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week, spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!